Welcome back, Pre-Algebra class, for another riveting episode of Mr. Chow Time. Mr. Chow Time, where's my pen? Why isn't it working? Oh, my thing's not on. I'm glad I got this captured in this video. Come on. Rational Numbers, Lesson 14, page 101 if you're following along the book. Vocabulary. What is a rational number? Well, it's any number that can be written in the form of a over b, where b does not equal 0. If you can write it like this, then it's a rational number. For example, let's see if this is a rational number. Well, this is not in the form of a over b because it's a mixed fraction or compound fraction number or whatever you want to call it. So can we convert this into the form a over b? We sure can. We can multiply 6 by 6, and that's 36. We can add 1, and that'll give us 37. And then we just put it right over the original denominator, which is 6. 37 over 6. So indeed, 6 and 1/6 is a rational number. Go ahead and try it yourself. Is this a rational number? Welcome back. It sure is. We put it over 1. All right. How about repeating decimals? Well, terminating repeating decimals, as you might remember, are decimals that are just decimals, right? Decimals like 0.34. It repeats forever with a 0 here. So there's 9.125. It also repeats forever. They're both terminating decimals because the repeating digit is a 0, right? So can we rewrite these as decimals, fractions? We sure can. We sure can. So this number has a tenths place and a hundredths place. Why is it called tenths and hundred and not some other name? Well, this has a hundredths value, so it is the tenths value, which is 3 over 10, and the hundredths value, which is 4 over 100. Yeah. So if we add these together, we get 34 over 100. And another way of just doing this a little bit easier than having this step is if you know that you have two decimals, two values after the decimal, then you have 2 zeros in your denominator. So let's do that again. This is 9.125. It has 3 values after the decimal. So that means we know we're going to have 3 zeros in the denominator. And then we just put the numerator right there. That's just the number that we originally had. Then we have to rewrite this as a fraction, right? So this is 9,000, right? Because we're going to multiply this. 9,000 plus 125. 9,125 over 1,000. Yay. Okay. So, I want you to do these on your own now. Welcome back. All right. So the first one is 5 and 875 over 1,000, which is 5,875 over 1,000. Okay, second one. Boy band music accounted for 0.35 of the total music sales in a recent year. Everyone loves those boy bands, right? So the total music, this is the same thing as 35%, 0.35. And the total music is 100%, right? Which is also the number 1. So this is 0.35 out of the whole of 1, right? The whole of 1. So basically we could say this is also 35 over 100. There it is. But with both of these numbers, I would want you to reduce them Yeah. So this would be, divide this by 5, that's 7 over 20. And then for this one, let's see. If we divide this by 5, it's 1,175. And this is 200. But we could divide both by 5 again, which is 235. And then this would be 40. And divide by 5 again, which is 47 over 8. Yeah, 8. And that's as far as we can take it. 47 over 8, 7 over 20. Alrighty. But what about bar notation? Dun, dun, dun. So let's say we wanted to write this as a fraction in simplest form. So this number 0.6 obviously goes on and on and on, right? So we don't know how many zeros to put. In fact, it would be an infinite number of zeros. We can't write that as a fraction. Does that mean that it's not a rational number? No, it does not. There's a neat little trick. So this number 0.6, it goes on forever, right? And we could give it a variable name, such as n. And so if we multiply n by 10, if we multiply it by 10, then we get 10n, right? And that means we'd have to do the same thing to the other side, which means this would be 6.6 repeating, right? Well, now we could subtract this n from both sides. And remember, n equals 0.666 repeating, right? So we're basically subtracting 0.666 repeating on this side, which means that all of the decimal places would cancel each other out. Does that make sense? If not, please come ask me in class. And that would give you 9 n's, right? There's only 9 n's left. And over on this side, all you would have left is a 6. Because all the decimal places have subtracted out. So then you can just divide both sides by 9, and that gives you n. And this is the fraction equivalent. 6 over 9 is the same thing as 0.6 repeating. So neat, right? And then you would just divide both by 3, and that would give you 2 over 3. Now we're in simplest form. So here's another example. I want you to do this by yourself, but remember this one has 2 digits after the decimal point. So you wouldn't multiply by 10 anymore. This time you would multiply by 100, because you would multiply it by the number of numbers that are repeating, if that makes sense. Does it? Did I explain that correctly enough? Let's just do it together. Okay, 0.424242. We'll make that equal to n, right? And we're going to multiply both sides by 100 because we want to get the decimal past the repeating portion. So now we're going to have 42.42 repeating, and that's going to be 100n. And we're going to minus one of the n's, and we're going to get 99n equals 42. Divide by 99. N equals 42 over 99. 42, that divides by 3, right? Yeah. So this would be, so what is that, 14? Oh boy, 14. I believe it is. If I'm wrong, just tell me. 14 over 33. Is that reduced all the way? Yeah, I believe it is. All right. So there's your answer. So I want you to do, I don't know, 0.32 repeating on your own. do this problem on your own. And we're back. Okay, so 0.32 equals n. Multiply both sides by 100, 32.32, repeating, subtract both sides by n, 99n equals 32, divide both sides by 99, n equals 32 over 99, and does this? I don't think so. I think this is simplified. All right, good job. Here's our key concept of any rational number is a number that can be written in the form of a over b, where b is not 0. This is a little diagram here of all the numbers. When you first started counting, you were counting what's called natural numbers. These are the numbers that that basically exist on your fingers, right? Like 1 and 2 and 3. This does not include 0. Then we learned about whole numbers. Whole numbers include the number 0 and all of the natural numbers inside of it. Then we learned about integers, which then adds all the negative numbers, the opposite numbers of the natural numbers. Then we're now learning about rational numbers, which are numbers that can be written as a fraction. And then there's another set of numbers called irrational numbers. That is numbers like pi, or numbers that repeat but never, that's a 3. Never, I'm sorry, that don't repeat. And are, that don't end, but also don't repeat. Goodness. Okay. And then these numbers, these are all called real numbers. Oh, can you even see that? Real numbers, the rational and irrational numbers. And then there's another set of numbers off to the side that are called imaginary numbers, which, you know, you won't have to worry about yet. We're not there. We're just here talking about rational numbers. I just wanted to give you some of those other words so that you'll have heard about them. Okay. Identify all sets to which each number belongs. So, what kind of number is this? Is this a natural number? It is not. Is it a whole number? No. Is it an integer? Nope. Is it a rational number? Yes. So it's a rational number. And that's the only set to which this number belongs. Okay? Some numbers, like 1, are included in natural numbers. It's a whole number. It's an integer. It's a rational number. Other numbers only fall into one set. Here's another number. Does this number repeat? No, it does not. Well, I'm sorry, it does repeat. No, it does not repeat, but it goes on forever. But there's not a pattern that it does over and over again. It kind of does look like it has a pattern, but the number itself does not repeat. So this is a number that we cannot write as a rational number. This does not belong to any set that we've learned about so far. Does not belong to any of these sets that we've learned about. Rational, integer, whole, and natural. Those are the only ones that we're talking about today. Does not belong. Okay. The last one I want you to do yourself. 0. Welcome back. This is a whole number. It's an integer, and it's a rational number. Okay. Thank you. Goodbye.